All right, here we go. Section 4.3.1. We are now going to be looking at the trig functions extended all around a coordinate plane. So first off, let's refresh our memory here. Find cosecant. Okay, we want to find cosecant if secant is 10 over 7. So secant theta is 10 over 7. So we need to remember our ratio for secant. So secant is hypotenuse. Remember, it's the reciprocal of cosine. So hypotenuse over adjacent. So when we're looking for cosecant, we need to set up our triangle with the information that we're given. So since we know here, I'm going to say this is my angle. It doesn't really matter which corner you put that in. We have our right angle, and then we just need to put theta somewhere. I don't know anything about theta, and that's okay. I don't need to know anything about theta. I just know that secant is hypotenuse over adjacent. So my hypotenuse is 10. And remember, adjacent, it means right next to. So that's this side length down here. That's right next to my angle. So that is 7. So to find cosecant now, if we remember, cosecant is the reciprocal of sine. So the reciprocal of sine means that this will be hypotenuse over opposite. Well, I know my hypotenuse, that's 10, but I don't know opposite. So what I need to do is I have to figure out that side length. Well, this is a right triangle. So right triangles have this nice little formula that help us find side lengths when we don't know one, and we do know two of them. So right now I know 7. Now 7 can be A or B. That doesn't matter because those are in the same spot. Adding and squaring are commutative, so it doesn't really matter where we put that. I'm just going to put it here for A. B is what I'm looking for. That's going to be this piece over here, the opposite side of my angle that I have drawn here. And then C is the hypotenuse, and that's 10. So we square this is 49. This is 100. So we have B squared is equal to 51 when we subtract that over. And then normally when you do a square root, you would put the plus or minus. But since this is talking about a triangle, we don't have a negative side length of a triangle. So this is just going to be square root of 51. Okay, so now we're ready to answer the question, what is cosecant? We need to find cosecant of this angle. So cosecant is hypotenuse 10 over opposite square root of 51. And remember, the only time we need to rationalize to simplify our fraction is if they have a common factor, and 10 has factors of 5 and 2, and 5 and 2 do not go into 51, so I don't need to rationalize that. I can just leave it like that. Next up over here, we need to find all 6 trig functions when I know theta is pi over 3. So if you do your conversion to degrees, you'll find out that this is the same thing as 60 degrees. And that's helpful because, let me change the size of this here. That's helpful because that tells us that we're using the 30, 60, 90 triangle. So I'm going to draw my triangle here. So here's my 90 degree, here is 60, and here is 30. And now again, this is a triangle you should have memorized. And we should know that the hypotenuse is 2. Opposite of 60 is square root of 3. And then opposite of the 30 degree is 1. All right, so this is a triangle you should have memorized by now. And if you don't, again, the 30, 60, 90 and 45, 45, 90 triangles we should have memorized. So now we need to find all 6 trig functions of this. So I'm just going to go ahead and make a list. So sine of pi over 3. And then I like to regroup, or not regroup, I like to group these together with their reciprocals. So cosecant pi over 3. So once I find sine, I can just do the reciprocal and get cosecant. Cosine of pi over 3, and its reciprocal is secant. So secant of pi over 3. And then lastly, tangent of pi over 3, and its reciprocal, cotangent of pi over 3. All right, so here we go. Again, this little acronym can be very helpful for us when we are trying to find our trig functions. We learned this SOHCAHTOA, which means sine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, which again, we use that over here to figure this out. And tangent is opposite over adjacent. All right, so here we go. Sine is, so this is the angle pi over 3 that I'm looking at. Okay, 60 degrees, pi over 3. So sine of this one, opposite is square root of 3. And the hypotenuse is 2. So square root of 3 over 2. And then again, for cosecant, since it's the reciprocal, I'm just going to flip that. 2 over square root of 3. And I don't need to rationalize it. If you want to, 2 square root of 3 over 3 is fine, but you don't need to do that. Back up to my triangle. Cosine is adjacent, so 1 over hypotenuse is 2. And then the reciprocal of that is just 2. And then tangent of 60 is opposite over adjacent. So square root of 3 over 1, which is just square root of 3. And then when I do the reciprocal, I get 1 over square root of 3, or adjacent over opposite. Same thing. All right, so I'm going to move through the notes here. If at any point you need to, you can pause, rewind, just rewatch the video or anything to pick up on any of the pieces that you may have missed the first time through. So I'm going to go through these notes. If it's a little too fast for you, just pause it as you need to take your notes. So we are going to learn about how we measure angles in the coordinate plane. So we have positive and negative angles. So first of all, here's my coordinate plane, right? Big plus sign. When we measure positive angles, we are always going to start over here. Okay, on the positive x-axis, that's where we start. Positive angles are measured in the counterclockwise direction. So if we see a positive 50 degrees or a positive 120 degrees, that's always starting here and measuring around counterclockwise. When we measure in the negative direction, we still start at the same spot. We still start right here, but now we're measuring around in the clockwise direction. So these are negative angles, like negative 90 degrees or negative 200 degrees would be up here, and this kind of works all the way around the circle in both directions. So that's how we measure angles, okay? The other thing that I want you to take note of here is a couple of things. First of all, we learned way back probably in middle school our different quadrants, right? This is divided into 4 quadrants. That's why it's called a quadrant for 4. So our quadrants, the way that they are numbered is because of the way we measure angles. Okay, so this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And then the other thing I want you to take note of in here is that all of our trig functions are positive and negative in exactly 2 quadrants, okay? So this is where our positive trig functions happen, okay? So the positive trig functions, first of all, up here, everything is positive. All of the angles, all 6 of them are positive up here. In quadrant 2, sine is positive. And if sine is positive, that also means that cosecant is positive because they're reciprocals, and reciprocals just flip the fraction. It doesn't change the sign. Down here, tangent. I don't know why I made a capital T there. Tangent is positive, and then that also means that cotangent is positive. And then over here, cosine is positive, which also means that secant is positive. Okay, so that's another thing that's just helpful to remember. And if we remember, or we will learn eventually, that sine will be related to the y-coordinate and cosine is related to the x-coordinate. So, your x-coordinates are positive in 1 and 4 and negative in 2 and 3, where your sine coordinates are positive in 1 and 2 and negative in 3 and 4. So just a couple extra things that are good to have down in our notes right here. All right, coterminal. So what does this term mean, coterminal angles? Well, coterminal just means that we have 2 angles that have the same initial side and the same terminal side, yet they have different measures. So think about, like, if you've ever watched the Olympics, like the Winter Olympics or something, and somebody is on their snowboard and they do a 720. So basically where they started, they spun around twice, landed the same way that they were facing. So they started the same way and they ended the same way, but 0 and 360 degrees if they did one rotation, is the same thing as 720 degrees if they did 2 rotations. So that's kind of the idea here for coterminal, is we have these angles, they all start at the same spot, they all end at the same spot, but they have different angle measures. So let me show you what I mean here, and this is good to have your calculator for. So, make sure you have your calculator out. We're going to do some simple adding and subtracting. So some of you probably won't need your calculator, but it may be helpful for some of us. So here's my coordinate plane, and I am going to measure 70 degrees is, we'll just say, estimate, it's right about here, right? That's about 70 degrees. Going from here up to here is about 70 degrees, okay? Now, if I want to measure an angle coterminal, I'm going to take my calculator and I'm going to do 70 plus 360. So what that's going to do is it's going to start here. We're going to go 1 rotation around and then up to here. So 70 plus 360 is 430 degrees. They have the same starting point. They both started here on the positive x, but they have different angle measures, even though they ended at the same spot. They both started here and ended here, but they have different angle measures. So the easy thing is we just, whatever angle we're given, we add 360, and then we'll find a negative one by subtracting 360. So again, we take our calculator, we do 70 minus 360 to get me over to here, and that's going to be a negative 290 degrees. So starting here on the positive x-axis, going in a counterclockwise direction, ending at this same blue line, so same as 70 degrees, different measure because we went in a different direction. All right, so you can go ahead and pause the video and try these next two, or the next one. The last one's a little bit different because we're doing an angle measure in radians. But go ahead and try negative 135. All right, so 135 is going to be over here somewhere. So this is my angle I'm starting with, going from here to here, is negative 135. So first thing I want to do is my positive. So I take negative 135 plus 360. So that's going from here to here. And that's going to give me 225 degrees. And then one in the negative direction, just try to follow the colors here because it's going to get a little messy with all my swirls in the middle. So we go 360 degrees this way plus the negative 135. So we started here, there's negative 360 to here, and then negative 135 over to here. That's negative 495 degrees. Okay, so there's 2 coterminal angles for negative 135. All right, the last one, for some of you, this may be a lot easier just to change this over to degrees. So that's 252 degrees if you do that. But remember, if you do that, since this was presented in radians, we got to change it back to radians. So I'm just going to leave it in radians, and I'll go through it that way. You could do this on your calculator. 252 degrees is down here. So going from here to here is my 7 pi over 5. Now, instead of adding 360, what I'm going to do is add 2 pi. So what I'm doing is 7 pi over 5 plus 2 pi. And this will give me 17 pi over 5. And you might be asking, well, how did you get that? Well, you can get a common denominator. 2 pi is the same thing as 10 pi over 5, right? 10 divided by 5 is 2. So just get a common denominator and add them. 7 plus 10 is 17. Or if you do it on your calculator, you can just do 7 over 5 plus 2, and then make sure you hit that math fraction to change it into a mixed, it might give it to you in a mixed number. If it does, you want to change that to improper. So we leave it as an improper fraction. So that's my positive. So going from here is plus 2 pi to here, plus my 7 pi over 5 over here, gives me 17 pi over 5. And then the last one in the negative direction, starting here, going over to there. And basically what I'm doing here is I'm going to take, oops, I didn't want to erase my 7 pi. So 7 pi over 5 minus 2 pi. And when we do that, you're going to see you get negative 3 pi over 10. So that's negative 3 pi over 10. Okay, which you could just do the same thing here, just subtract 2 on your calculator. Make sure you change that to an improper fraction though. Okay, so basically what we're going to do with this information is we're going to take this, we're going to put a point on our coordinate plane and create a triangle out of that to find our 6 trig functions. All right, so if you look at the next set of notes here, that's what all this information is. Now this means nothing different from SOHCAHTOA. Sine is opposite over hypotenuse. It's y over r. What we do need to remember now is that r is a distance. It's being defined as a distance. So r cannot be negative. So if you end up with a negative fraction, that needs to come from either x or y. Okay, r is always positive. So you maybe make a note of that. R will always be positive. So, if we end up with a triangle, let's say we draw, we end up with a point over here, and we draw a triangle like this, it always connects with the origin, and then we drop it down to the x-axis. This will be r, y is our value that goes up and down, and x is the value that goes left and right. So wherever we are in the coordinate plane, x will go left and right, and y will go up and down. Okay, so let's go ahead and do an example of this, because you may be looking at that thinking, I have no idea what's happening here. So let's look at an example. So we have this point, -3, 4. So we go back, -3 would go to the left 3, +4 would go up 4. So we would have this point right here. That's our point, -3, 4. And then we, again, connect that with the origin, connect it with the x-axis. -3 is my x value. That goes down here. 4 is my y value. That goes over here. So now I need to find the hypotenuse. Well, how do we find the hypotenuse? Again, we know this nice little formula that helps us to determine a missing side length from a right triangle. So I'm missing my hypotenuse. So this is -3 squared plus 4 squared equals c squared. So you do the math and you get 25 is equal to c squared, and that means c is 5, sorry, not 25. That means c is 5. So I know my hypotenuse is 5. Once we do all of that, now we're ready to do our 6 trig functions. Now, my angle measure is right here. This is theta, but I don't know what theta is. I don't know what that angle measure is. I don't really need to know what that angle measure is in order to find all of the 6 trig functions, okay? So actually, I should correct myself. Theta is this measure here, okay? Theta is that measure. So sine of theta, I'm just going to use that. I don't know what it is. I don't know what theta is, but I can still find sine of theta, because sine of theta, I can either look at its y over r or its opposite over hypotenuse, right? We learned 2 different ways now to solve this. So from my angle, opposite is 4, hypotenuse is 5. So I have 4 over 5. Now, once I know sine, I automatically know what cosecant is, because cosecant is just the reciprocal. So that's 5 over 4. All right, let's keep going here. Cosine of theta, again, x over r or adjacent over hypotenuse, either way. Adjacent is -3. And the hypotenuse is 5. And now again, I know what secant is, because secant's just the reciprocal, so 5 over -3. And it doesn't really matter where you put that negative at. You could put it out front like that if you wanted to. All right, last one, tangent, or I should say last set, tangent and cotangent. So cotangent is y over x, which is opposite over adjacent from our old triangle stuff. So 4 over -3. And then once I know tangent, now I know cotangent. This is -3 over 4. All right, so we have another one of these we're going to do here to finish up. So you can go ahead and plot that point, work on this one, pause the video, try it, and see what you get. So 4, -6 is down here. This is my 4, right 4, down -6. We're going to connect with the origin, connect with the x-axis. We go to the right 4, and we went down 6. Now I need to figure out what is my hypotenuse. So again, we're going to do 4 squared plus -6 squared equals c squared. And you can do that, simplify it, you end up with 2 square root of 13. So that's my hypotenuse, 2 square root of 13. All right, now I'm ready to go with all my 6 trig functions. So sine of my angle, sine is opposite -6 over, again, we're looking at this, -6 over 2 square root of 13, which now we can reduce this, and we get -3 over square root of 13. And if you notice that these are all reducible, you could reduce it in your fraction, or in your, not your fraction, but in your triangle, and just divide them all by 2. And then it kind of helps you when you're doing the rest of the problem. So you don't have to reduce it a bunch of times. You just reduce it once there at the beginning. Square root of 13 over -3 for cosecant. Cosine is adjacent, which is 2 over hypotenuse, square root of 13, sorry. Let me clean that up. Square root of 13, that's better. Secant of theta, our angle, is square root of 13 over 2. And the last one's tangent of theta is equal to opposite -3 over adjacent 2. Cotangent, last one here, 2 over -3. All right, so that is how we now draw our triangles anywhere on the coordinate plane in any quadrant. We're going to draw a triangle, fill in our side lengths, and then find our trig functions from there. So, yeah, so that's pretty much it. Let me know if you have questions.